Hello, students. So, this is solving during the quarantine semester as an optional lecture. What we'll be doing in this lecture is we'll be talking about how you prove rigorously facts about trig identities. And let's start with a discussion of a trig identity that you already know, the Pythagorean identity. The Pythagorean identity says that sine squared of theta plus cosine squared of theta is equal to 1. And what does it mean to say that the Pythagorean identity is an identity? It means that no matter what number we plug into sine and cosine, that equation will be satisfied. An equation that's true regardless of what input you feed it is called an identity. An identity is an equation which is always true. So you know some other identities already. You know some things that are always true about trig functions. You know that tangent of theta is always equal to sine theta over cosine theta. You know that cotangent theta is equal to cosine theta over sine theta. You know that secant theta is equal to 1 over cosine theta. You know that cosecant is 1 over sine theta. And you know that those things are true no matter what the angle theta is, I guess as long as it's in an appropriate domain. There are the even-odd trig identities. You know that cosine is even, so cosine of negative theta is the same as cosine of theta. You know that sine is odd, so sine of negative theta is negative sine of theta. You know that tangent is odd, so tangent of negative theta is negative tangent of theta. There are the trig identities you get by adding over 2. You know that the cosine of theta plus pi over 2 is the same thing as negative the sine of theta. You know that the sine of theta plus pi over 2 is cosine theta. You know that the tangent of theta plus pi over 2 is negative cotangent theta. And those equations have all been very important, especially the Pythagorean identity, in that if you want to do things with trig functions, if you want to, say, solve equations that involve trig functions, you need to know stuff about trig functions. And the more things you know about trig functions, the more tools you have. So what we're going to do in this lecture is we're going to prove new trig identities and talk about how you prove new trig identities from the ones you already have. So let's start with this. Here's a thing that I claim is an identity. I claim that 1 minus the square of the tangent of x divided by sine x times sine x tangent x is equal to tangent of x plus 1 all over sine x. And let's try to figure out how to prove that. So I'll give, we'll just do some algebra. Let's try factoring. And maybe off to the side, it's often a good idea to come up with your proof in Scratchwalk before you write it down formally. So I'll be very informal. I'll write t for tangent and I'll write s for sine. And this, what I'll do off to the side, won't be the actual proof. It will be the Scratchwalk for the proof. So I don't ever want to see our Scratchwalk. So let's see, it looks like 1 minus t squared divided by s minus st equals t plus 1 over s. So let's just see what we can do with that. So certainly over here, it looks like maybe there's some factoring that we could do. Right, everything in the denominator has an s in it, so we could factor that out. So I could factor that as s times 1 minus t in the denominator. The top, I see 1 minus a square, and that should make you think of the difference of squares formulas, and I'll just remind you of the difference of squares formula really quickly. Difference of squares formula says that a squared minus b squared isn't a minus b squared, it is a plus b times a minus b. And 1 is a square, like 1 is 1 squared. So I can use that formula to rewrite the top as 1 plus t times 1 minus t. And in the Scratchwalk anyway, I'll try to indicate things that I want to be true but don't know if they're true with a question mark. That's not a standard convention, but I think it's a good thing to keep yourself straight, and I'll just leave the other side the same. Oh, but notice, I see an s in the denominator on both sides. So we can cancel those s's, and look at the fraction on the left-hand side. I see 1 minus t divided by 1 minus t. Those can cancel. And that leaves me with 1 plus t is equal to t plus 1. Yeah, that's a true fact. So let's do all of those same manipulations off to the side. So it looks like over here I only manipulated the left-hand side, so I'll just manipulate the left-hand side over here. 1 minus the square of the tangent of x divided by sine x minus sine x tangent of x by factoring is the same as 1 minus tangent, I think it was 1 plus tangent x I wrote on the other side, and it worked out pretty well. 1 plus tangent of x times 1 minus tangent of x divided by sine of x, 1 minus tangent of x. And then what did we do in the scratch work? Well, we canceled. We canceled 1 minus tangent of x with 1 minus tangent of x, leaving me with 1 plus tangent of x over sine of x. Oh, and check it out. That's exactly what I wanted. So I started with the left-hand side, I did some stuff, and I got down to the right-hand side, so that the left-hand side is equal to the right-hand side. The claimed identity is true. So as OMeric, I'm going to tell you something that I am absolutely going to require in your write-up of a proof of a trig identity. If you're going to prove something is true, you need to explain in detail what is going on in each step and why each step is correct. When you say, when you do this manipulation, what are you doing? You're factoring stuff, so you better tell me that you're factoring. In this step, we canceled, so you better tell me that you canceled. I want you to include words in your proofs. Every step needs explanation. And as a consequence, your proofs will wind up being maybe a little bit long, but that's appropriate. Better to be long-winded than is it to not include enough detail. Let's do a similar one. Let's prove the following identity. Tangent of x times the cosecant of x is equal to the secant of x. And maybe again, we'll go off to the side and we'll see how the proof will go. And then we'll go put pencil to paper on the other side and actually write it down. So let's try to write down tangent of x times cosecant x and see what we get. Well, I know what tangent is. Tangent is sine over cosine. So this is sine x divided by cosine x times secant is 1 over sine x. Oh, but those will cancel, right? That's equal to 1 over cosine x. And that was just messing around. Let's see what you actually want to prove. I want to eventually get a secant of x on that side. So, with your eye on that prize, if you can tell me why 1 over cosine of x is equal to secant of x, I'll be happy. Oh, but 1 over cosine of x is equal to secant of x because of the trig identity that says secant is 1 over cosine. So, let's do that. Motivated by the proof that's off to the side, if I want to prove that tangent of x times cosecant of x is equal to secant of x, let's start with the more complicated side. Tangent x times cosecant. We'll express in terms of sine and cosine. So tangent is sine x over cosine x. Cosecant is 1 over sine of x. And I see a cancellation. I see that the sine of x's cancel. So maybe by canceling the sine of x, because right, you can. Here sine of x is being divided by cosine, but here I divide by sine of x. Those will undo each other. Equal to 1 over cosine x. But what is cosine of x? Well, I can re-express that in terms of secant and get myself secant of x. Great. So let's keep on going. So there are two other identities that I think I want to talk about. They're the other Pythagorean identities. They're the identities that tangent squared plus 1 is always secant squared. There's one of the Pythagorean identities. And the other one is that cotangent squared plus 1 is equal to cosecant squared. So those are the two Pythagorean identities. Let's talk about why they're true. So, Maybe I'll do the same as I did before. I'll go off to the side. Well, the more complicated side in the that Pythagorean identity is the side with the tangent. So let's try to express tangent squared of x plus 1 by doing some stuff. My eventual goal is to get that down to secant squared of x. Well, let's start with getting things in terms of sines and cosine. What is tangent? Tangent is sine over cosine. So tangent squared of x is sine squared of x divided by cosine squared of x. And I'll just leave the plus 1 alone. And let's see, I see a fraction plus a number. So how do you add a fraction to a number? Well, you need to get a common denominator by re-expressing that number as a fraction with that same denominator. And you know how to do that. That'll give you sine squared x divided by cosine squared x. And what is this one? That one is cosine squared x divided by cosine squared x. And you'll notice that I'm being a little bit sloppy, right? I'm not writing down any WODs, and I'm leaving lots of stray pen marks. This is just the scratch walk for the proof, so I'm explaining the scratch walk as I generate it. So once I get down to here, and no one should ever see your scratch walk after you've come up with your actual proof. The scratch walk is just for you. I never want to see your scratch walk. This is the same thing as sine squared x plus cosine squared x divided by cosine squared x by adding fractions. Oh, but look at that numerator. That numerator is something that we are very familiar with. That is the left-hand side of the Pythagorean identity. So by using the Pythagorean identity, this will become 1 over cosine squared x. And let's just remember what the goal was. The goal is to show that that identity, that tangent squared plus 1 is equal to secant squared. So I want to take this and turn it into something involving secant. Well, 1 over cosine is secant, so 1 over cosine squared is secant squared of x. And that completes the proof, at least the scratch walk for the proof. Now, we better go and actually do it. Oh, and you'll notice one more thing. That variable, it was called theta. That's theta. I switched to x. That would be a bad thing in your actual proof. You should probably use the same variable or explain why you're changing the name of the variable. But in the scratch walk, since no one sees it, it doesn't matter. So let's do this. So tangent squared plus 1. And let's follow the same things we did to the left. And notice in this step I'm going to do multiple things. I'm going to express in terms of sine and cosine and get a common denominator. So let's do that. Tangent squared of theta plus 1 is sine squared theta over cosine squared theta plus 1, which is the same thing as sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta. We can now add fractions easily. This will give us sine squared theta plus cosine squared theta all over cosine squared theta. Just like we saw before, the numerator is the left-hand side of the Pythagorean identity. So by the Pythagorean identity, the numerator is 1. And I still divide by cosine squared of theta. But what is cosine squared of theta? Well, it is secant squared of theta. So you can get that just by re-expressing in terms of secant. Wonderful. So, the next thing on the agenda is to prove the so-called, yet another Pythagorean identity, one that relates cotangent with cosecant. And I'm going to encourage you to take a moment, walk out this argument on your own, and then come back and we'll talk through it. Okay, good. You did that. Let's talk through this argument, and maybe I'll begin by doing some scratch walk off to the side. So I want to try to explain why cotangent of theta squared plus 1 is always equal to the cosecant of theta. And there's one side that's obviously more complicated than the other, the one with cotangent squared plus 1. So let's start with that more complicated side and simplify it. So what do we see on that side? We see cotangent squared of theta plus 1. And let's just try to simplify. And we'll do the same simplification as we did in the example that we just finished. We just finished. It was several hours ago for me. You don't need to know that. Cotangent is cosine over sine. So that's cosine squared theta over sine squared theta plus 1. But you know what to do now. This is a fraction plus 1. So I'll get a common denominator and add these fractions. That'll give me cosine squared theta plus sine squared theta all over sine squared theta. And cosine squared plus sine squared, that's 1 over sine squared theta. So let's try to work that out. So let's do it. Starting with the more complicated side, and simplifying, what do we get? We get cotangent squared of theta plus 1 is equal to cosine squared theta over sine squared theta plus 1. And this is just true by expressing in terms of sine and cosine. Excuse me. That in turn is the same as, well, we get a common denominator. Cosine squared theta over sine squared theta plus 1. Oops, I haven't done anything if that's what I write down. Plus sine squared theta over sine squared theta, getting a common denominator. Equals cosine squared theta plus sine squared theta all over sine squared theta by adding fractions. Equals 1 over sine squared theta by Pythagoras' identity. Equals sine squared is cosecant, 1 over sine squared is cosecant squared theta by expressing in terms of cosecant. Which is exactly what we wanted to put. We wanted to show that cotangent squared plus 1 is always equal to cosecant squared, which we have accomplished. Nice. So, I think that this is a good moment to break the first video. Those represent, if you like, the simplest examples that we'll do. During the next video, and maybe video after that, the examples will get increasingly complicated. I strongly encourage you to, as much as you can, walk through the rest of these on your own, and then come back and see if your proof agrees with my proof. If you have a different proof, that doesn't necessarily mean it's wrong. It just means it's a different proof. You can prove something in many different ways. A thing which I want to absolutely make sure you do as you walk through these on your own is you include all of the words you need to explain what's happening. So you'll read all of these words. Here I've in detail explained what's going on in each step. Your write-up must accomplish that. That's one of the big takeaways. If you're proving something is true, you need to explain every detail of what you're doing. Great. So I'll talk to you again real soon. Cosine. Oops.